welcome Amith Reddy to the workshop today, Learn How to Hack a Car, which sounds kind of cool. And we got a lot of interest in this one. So there's a lot of people pouring in. I'm Dan Maloney. I'm a staff writer here at Hackaday and a community engineer at Hackaday.io. I'll be the moderator for this. Amith is a recent Mechatronics Engineering student, or recent graduate. To pass the time in lockdown, he decided to pick up car hacking, which in another place and time might not have been considered a terribly good thing to do. But I'm sure he's been totally legal and totally above board on this, as all good hackers are. And he's willing to pass this information he's learned down to anyone who's interested. And that's what we're going to do today. So take it away, Amit.
I just seen a lot of people pour in the last couple of minutes. We dropped a link in the chat for where to download some files. I'm going to drop it again. Just trying to find the chat window. So if you guys can go to that page and download, it'll say like workshop files.tar.gz. So, and uncompress it, and we're going to use those files for the workshop today. I'm going to just keep going through the workshop while you download those, while you download those files. Okay, so what we're going to do for this workshop is we're just going to discuss why you might want to hack cars. What are some difficulties in hacking cars? Some interactive portions. We only have like 4 exercises. I asked this a little bit before the workshop started. If you could, if anyone would want, I would like some volunteers for each exercise to help with the pacing, because I don't want to, when I get nervous, I talk really fast. So it'll be something like I'll do a step and you try to follow, and if some and so that way I can keep I can present in a slow manner and not speed through everything and like keep leave everyone behind. So if that's something you can do, please volunteer. I'll ask for volunteers before each exercises. So, and after the interactive portion, I'm going to do some demos with Python and SavvyCAN. And to wrap it all up, I'm going to give you guys some additional resources that you can read up on and learn more skills. Okay, Dan already introduced me, but I'm about 100 hours into this hobby, and I still consider myself like an expert beginner. I'm just going to try to save you as much time and frustration I experienced in the beginning. So hopefully it'll help you out. So car hacking, why do it? To learn automotive systems. It's fun. Like if you want to extend a car's functionality, it also exists. Some systems in automotive systems exist in like other systems, like heavy machinery and robotics. I worked in a company that made heavy machinery for like the mining industry, and a lot of their machines ran on CAN networks. And like if you ever need to repair your car, I think it's a good skill to have. Michigan just recently passed the right to repair, I believe. So like car information is going to be more available starting in 2021 or 2022. So that's something we can look forward to. It'll probably charge us a lot of money to get access to it, but at least we have it available. So some of the obstacles related to car hacking is just the sheer amount of systems and within a car and the complexity of each system. So just to list off a few, just like the wireless entries, like some cars have cellular connection, satellite radio, GPS, radar, tons more speakers, infotainment systems, like auto braking systems, lane keep systems, advanced cruise control. And there's like a ton more that I didn't even mention. And they all require certain hardware, specialized hardware to like make sense of, like logic analyzers, software defined radios, et cetera, et cetera. And there's differences between makes and models, and even models between different model years. So it's kind of hard for people to communicate that information. So let's say if I'm working on a Honda CRV in 2016 and you're on a different car, it's kind of difficult to share information that will make it easier for us to like build off each other's work. And obviously automakers want to hide the information to hinder repair and stuff. So, and that's one of the reasons that I used ICSim to introduce beginners. So, because we don't have to we don't have to use the same car or anything like that. So before I go into ICSim, so the easiest way to get started car hacking is to get started using the OBD2 port. So OBD2 port is like a diagnostic port. It's found in all cars built in the last 20 years or so. It's used for diagnostic purposes and emissions testing. So the European versions have the same thing, but it's physically and technically identical, I think, to this port. So if you're in Europe or elsewhere, I think you'll have something similar, if not the exact same thing. So the regulations only define certain pins to be certain things, but everything else, it's up to the automaker's discretion. So the green pins are what we're going to focus on today. That's the CAN bus. But I'll go through some of the other pins just for quick reference. So the blue pins are a PWM signal. And the fourth pin is just chassis ground, and fifth pin is signal ground. So 6 and 7 are CAN high and low. And 715 are K-line and L-line. And those are very, very low bandwidth systems. And that how that network works is that there's one master and many slaves or whatever, or followers, however you want to define them. So that's one reason that CAN is better, because there are a lot more nodes on it, and it's also much higher bandwidth. I'm going to omit the hardware implementation and low-level details on CAN frames for this workshop. And I'm just going to give a high-level overview of how CAN works. So let's say we have all these all the blue squares are nodes, and like if you want to connect them in a traditional SPI bus or UART, we need to share a lot of wires. But with CAN, you just have to have 2 wires between the whole lot of them. And one complexity that comes up with this issue is that if multiple people want to talk at once, or multiple nodes wants to talk at once, how does who gets to go first, and how does that get decided? So there's something called like the arbitration process for CAN networks, and basically, I just got cut off here. Basically, all the nodes have an arbitration ID, and the node with the lowest arbitration ID gets to go first. So everyone else who's a higher number than them backs off and lets them communicate. Then they enter into arbitration again, then go into it. And you just repeat it until everyone has its chance to speak or broadcast into the network. So CAN has the highest bandwidth out of all the car networks, except Ethernet, car Ethernet, automotive Ethernet. More cars are shipping with Ethernet nowadays. It's very easy to add nodes and extend the CAN network. And it's very simple to implement physically. CAN is actually, the limits of CAN is like, it's very low bandwidth compared to like Ethernet or some other protocols. I think most cars have something like 500 kilobits per second to 1 megabit per second. So very, very limited bandwidth. And each CAN message can only be 8 bytes long. So this can be poor or limiting for hard real-time systems if you need that. And you just like, if you have a message that's more than 8 bits, you have to break it apart over multiple CAN messages. So that adds complexity to your system. So some parts of so how does a CAN packet look like? So all CAN packets have an arbitration ID and data, like a payload, I guess, of up to 8 bytes. So some can have up to 1 or 2 bytes, all the way up to 8 bytes. So for example, here, this 0x300, so hex decimals, we're gonna use hex decimals for the entirety of our presentation today. So that's the ID, and all the 8 bytes I think I have here is the data. So, okay, we're gonna try setting this up. Do an exercise for the setup. Then I'm gonna go through the controls for the ICSim and how to get that set up and what controls do what. And if you downloaded the workshop files, in that workshop files, I have a workshop PDF, which is just a PDF of all the slides I have. So if you ever need to know what commands I'm running, you can just copy and paste into it, into your terminal if you miss what I entered. Okay, so I'm gonna just get started. Is everyone following along so far? Okay, and there's a message from Leonard. Well, I guess you guys are having a different conversation. Oh, no. So there can be multiple CANs. They can, I think, automotives, because if you remember the OBD port I showed, the undefined, the ones that are undefined, it's up to the manufacturer's discretion. So they can add multiple CAN networks or add their own proprietary network. So, so like there's a slow CAN, which is like GM CAN or GM LAN, I forget what the word is. So that's lot slower. No idea, honestly. Okay, so let's try setting it up. I know some people had difficulties installing ICCAN and everything. So I'm sorry, but I've been told by Dan that they're gonna record this and post it later onwards, most likely. But so if you got, so you still have chance to go through this workshop and get the benefit. But even if you don't get that, I think you still get some benefit from just watching me do the interactive exercises. And also, and it's only half the workshop is interactive. So the other half is just me doing demos. Okay, so is there any volunteers? Is there any volunteers? Because I'm gonna run through this setup right now. So
I set up everything, but it's on a separate netbook. So I'll have to type comments. If you think that that's slow enough, I could be that one.
Okay, so is your name Salek? Is that how to pronounce it?
Salek.
Oh, Salek. Okay, so okay, I'm just gonna run. Can everyone see the terminal right now?
We've got one person saying that they can't see the screen, that your screen is black, but I can see it fine. And I think also, Amith, you've got something obscuring part of your screen, right? You're trying to hide some information there, so you don't dox yourself, that kind of thing.
Right now, only thing you should be able to see the exercise. This thing. I don't know if you can see my mouse and the
You can see your
terminal
mouse,
here.
but there's like a cross-hatched area over on the left-hand side of your screen that looks like some sort of I'm sorry, on the right-hand side of your screen. Yeah, you're moving a window around that's just showing up as cross hatches.
That's a zoom. That's
Zoom
a
in.
Oh,
Oh,
okay.
yeah.
So I'm just going to try to shrink it down a little bit more.
Okay.
I'm going to just minimize chat, so you'll have to keep me posted.
Sure, I'll keep you posted.
So, is that better? Can people see it more?
Yeah.
There's more of the screen visible now. Yes.
Okay.
Thank you.
Okay. Okay. So clear. I'm just going to clear my terminal. So I'm going to run sudo mod probe can. And I'm just enter my password. Are you good? I think you muted Salad. Can I unmute him? Dan, can I unmute Sal?
Yeah, I just asked him to unmute.
Okay.
Okay, I'm unmuted.
There we
go. I'm currently running this, so let's try. Try to.
You already have everything set up, the ICSim and everything.
Right now the simulation is running. I have a control panel and IC simulator because I started it before we started.
Oh, okay. I'm sorry.
But, okay, let's go. Let's go one thing then another. Okay, so sudo mod probe. Say, do you have a script for this?
I don't have a script.
Shell script.
No. It's just 4 commands, so we can get through it pretty quick. But like if you can't see my screen, I have a PDF that I sent it with the workshop files, so you can which is just the PDF of my slides, so you guys can copy and paste or look at it closely on your own screen if you can't see my screen. So have you run the first command already, or you already set up? You already have everything running.
I am already set up, but I will get another terminal ready so that I can follow you again.
Okay, you can. Is there anyone that's not doesn't have it running already? I don't want.
I think Hiran said that he or she would volunteer.
Okay, so maybe we can do that instead.
Hi.
Hello.
What would you like me to do?
I'm just going to run some commands. Can you hear me?
Okay. Yes.
Yeah, so I'm just going to run some commands. If you can follow along, I just want you to pace me because I don't want to run through it really quickly and leave people behind. So have you run the first command already? Sudo mod probe can.
Okay.
Then the second command is sudo
so.
mod probe vcan, and you press enter. So the next command, sudo IP link add dev dev vcan 0 type vcan. I already have it running in the back, so that's why I got that error, but you shouldn't get that.
I think I'm missing some basic setup stuff.
Do you have an error? What kind of error do you have?
Not that I don't have any of the libraries and other stuff installed. I was just actually joining this workshop for fun, but I am a volunteer for Remoticon.
Oh, so you don't have it in, oh, you didn't have it installed. Okay, yeah. Okay, okay. I guess
No, I didn't have a chance to.
Okay, that's fine. I'll just run through this commands for everyone else. But I guess because everyone's on a different place at the workshop, so.
Yeah. Oh, sorry, I did it again.
Okay.
Thank
Yes,
you.
Dan?
Sorry. I was going to say your pacing seems fine, so I don't know we necessarily need someone to help us pace. I think we're doing okay.
Okay, so okay, we'll just pivot to something else.
Yeah, I agree.
Okay, so I added the vcan link, so I'm going to do the next one. Sudo IP link setup vcan 0. So then when I run my IP link, then I'm just going to do my CAN. So I have it up here. So now I'm going to try running ICSim vcan 0. So that's working. So in another terminal.
Can you please slow down?
Slide down what?
Can you please slow down?
Oh, slow down. Okay. Does everyone have the ICSim running right now? For those who are able to get it running.
Looks like
Okay,
we're getting
so,
a lot of runnings in the chat.
Okay, so I'm going to open another tab. Then I'm going to run my controllers. So I'm in the folder where you built your ICSim. So you can see here I have my controls and my ICSim executable. So now I'm going to run my controls. I need the vcan 0 again. Otherwise, it doesn't know where to pass the information in. So I'm gonna just make this smaller.
Okay, I don't know about anybody else, but I need to see the terminal at the same time, and I'm
okay.
already behind, and you've already lost me.
Okay, so where did I lose you?
/ICSim.
Mm-hmm.
Okay, thank you. I can see it now.
So ICSim vcan 0. Can you tell me if you can get that running?
No such file or directory, so I don't know what's happened.
Did you? You should.
I think you need to compile it. You don't have the executable.
So yeah, like if you built, I'm just going to close it. If you built your files, like if you ran make on your ICSim directory, the one you downloaded, then you'll be able to run it. Have you ran make on your ICSim stuff?
Yes, I have, but there was an error that said something to do with SDL2.
Oh, okay. So you have to go through another process. So I'm sorry, I can't do that right now.
That's okay.
I'm sorry about that. Like in the public chat, if like afterwards you can go. There's someone who already solved that issue. So.
Okay, thank you.
Okay, thank you. So I'm going to go controls, vcan 0 again. Okay, so no, I hope no one needs a terminal, but so with the controls selected, if I hold down the up arrow, you should see the up arrow moving. So if I hold down the left and the right arrow keys, you should see the left and right blinking. And the door unlock is a little finicky. So basically how you unlock all doors is you hold the right shift, then you tap the left shift. And it takes a second. You might have to do it again. Or the other way around, maybe. Okay, there we go. And I just refer to my instructions: hold right shift and tap left shift. Okay, it's a little finicky, the display, so it's kind of hard to get it running sometimes. Okay, so yeah, so like if that's fine, that means it's unlocked. So if it's completely locked, you should hold down. Okay, I guess I mixed up the instructions. So it's the opposite of what I wrote down: to lock all doors and unlock all doors. Yeah, you need 2 terminals, Chris. So I think it's you hold down left shift and tap right shift to unlock, and you hold down right shift and you tap left shift to lock everything. Okay, so I'm going to move on to the next exercise. So there's going to be a lot of terminals, so just speak up if I'm obscuring anything. So I'm just going to minimize the terminals that have the CAN controllers or the ICSim stuff running. So now I'm going to open up a new terminal. Then I'm going to run CAN dump. So this is part of the CAN utils you guys installed. So I'll just say CAN dump vcan 0, and we'll see what it's doing. So I don't know if Zoom is capturing this. It's pretty, it may not be fast enough, but it connected, a CAN dump being just connected to the virtual CAN interface and just dumping all the messages that it sees onto your terminal. Can people see this?
Yeah. Mm-hmm.
Okay, thank you.
Yeah, that's scrolling nicely. That's a good update.
Okay, so now one other feature we can do of CAN dump is that we can run CAN dump and dump all the files into, dump all the messages into a file. So I'm going to run CAN dump dash capital L, arrow key, I guess. I don't know how you say that word. So I'm going to call mine first.log and vcan 0. So that's basically recording in the background. And so we're going to try to do something called a replay attack. So we're going to record unlocking our doors and see if we can catch that message to unlock our doors. So I'm going to hold down left shift and tap right shift. So on my doors unlocked. So then I'm going to stop my CAN dump file. So if I do ls, I see that I have a first.log file there. So I'm going to just peek at my CAN dump or my log first.log. So head -n10 first.log, and you see this. These messages are like, this is a simulator, so it's just simulating a lot of different nodes. So if you see this, let's just do something with a little bit more readable, human readable. So I'm going to run my head command again, head n10 first.log, and I'm going to dump that into another CAN utils command called log to long. So it's a little bit more human readable. So each of these nodes, each of these IDs represents a different microcontroller. passing messages into the CAN bus. Okay, so let's just look at our a file that we let's look at how long our file that we just opened is. So if you do WC, which stands for word count, but it also counts lines. If you pass in the -L command, then you do first.log. So you can see there's 75,000 messages in that brief 30 seconds we had it running. The way you do a replay attack is you replay the file that you captured and see if you can get.
Morning.
Can you mute everyone again? I think.
I'm sorry to interrupt you.
Okay, I guess we were muted again. So, so the basic how it works is that you play back all the files all the messages you captured back onto the vCAN virtual CAN interface. By doing that, we can basically say that we can trick the system into saying that we are running that command, or the system itself is running that command. So I'm just going to lock my doors again. So I think it's hold right shift and left shift, or the other way around. Oh, I have to select my the window with the controller on it. So I have it locked. Oh no, I guess not. Okay, I'm just gonna wait to see if it's locked. Okay, it's locked. So I'm gonna use another CAN utils that you guys downloaded. It's called CAN Player. So I'm gonna pass in when trying to pull the log file, I get an error. Can you just, Ryan, you can just try using, you have to pass in head and 10, because it's such a big file, it can crash, it can give you errors. So if you pass in this command here, head -n 10, and you have to grep it, so you have to use this vertical separator and log to long. Or you can just do this. Oh, I think I made a mistake here. So here, what I forgot to include was you have to pass in the name of your file, first.log, and it'll work. So that's my bad. Okay, so CAN Player, and I think my instructions on the next slide. So CAN Player dash, I'm going to show you this -I, capital I, and pass in our file. Hopefully it works. And we'll just wait to see if it, I guess it's 30 seconds, so it'll take a while to get through everything. So while this is, okay, there, it managed to unlock the doors just by replaying these messages. So I'm just going to exit out of that. So basically, the whole, what we're going to do, you would normally do is that you would split, that CAN file, or the CAN dump log into 2 files and replay each of them, and to see which section of the, so if we split the original file into 2 files, so each one has half the CAN messages, then when we replay the first split, so if the first half, and we see if that message unlocks our doors again. If it does, great. That means there's that CAN message that we're looking for is in that part. Otherwise, we know it's in the other half. So, and we keep repeating this until we only have one CAN packet left. So that's the CAN ID that unlocks the cars. So because I'm not going to make you do this with 75,000 line file. That will take you for all night to get through, especially using command line utilities. If you look in your workshop files, so this is what I get after unzipping my workshop. So there's a file here called 100lines.log. You can try replaying. You can try replaying that file on your network. So I'm just going to navigate to my desktop. Sorry, navigate to my workshop files, I mean. So I'm going to go to the folder called ICSim. So I see there's 100 lines there. So I'm going to do CAN player again. -I. Okay, first, before I run that command, I'm going to make sure my car's locked. Oh, I have to select the controller again. So hold down right shift. Okay, there. So I'm going to run it again. I hope you guys can see what I yeah, it's 100 lines is much faster than 75,000 lines. So I'm going to try locking my doors again. Okay. Okay, yeah, so okay. So I'm going to run a so I'm going to run a command line utility called split. So -L. Then I'm going to run the 100 lines log, or pass in the 100 line .log file name. So I'm going to just because I'm just going to split it into 50 lines each, and I'm going to give a prefix of 2, and I'll show you what that does. So we split the initial 100 lines into 2 files called 2AA and 2AB. So when I'm going to run it again, I'm going to run the command again. What's the word? CAN player -I, and I note that my car's already locked. Then I'm going to run the 2AA file. So that's the first half of the thing. Oh, and it unlocks. So we can guess that it's in that part of the file. So I'm not gonna keep going through it until there's only like a couple lines left. So we can just check our work. So if you guys can read this, I'm gonna clear all the things. So I'm gonna run less, pass in 2AA, and I'm gonna pipe that into grep 19. Then I'm gonna run a command. Then I'm gonna try to find if there's anything that matches that line. So the CAN ID that of the message that unlocks doors is 19B. So we can check our work again. Oh, this is the wrong terminal. Whoops, where is my? Oh, there we go. I'm going to minimize this again. So we can do another command called CAN send. We're just going to copy the line we found. Control or right click. Now paste again. Then I'm going to hit enter. Oh, oops, I messed up something. Okay, I'm just going to lock the door so you guys can see what I just did. Okay, I'm gonna lock the doors again. I'm just gonna make sure it happens. Okay, so I'm gonna show you if you run the command. So it's unlocked. So we know we found the right ID number. Okay, thanks. I don't know how to say your name. Narizina. I don't know. I'm not that good with Linux, so thank you. So we confirmed that's the ID. So let's do something. Let's do the same process of finding IDs with using a little bit more interactive process. So we have something called CAN sniffer. Okay, I'm just gonna make sure I see everything. I'm just gonna lock my doors because I don't want it to blink. So I hope you guys can see everything on my screen because there's a lot of stuff on my screen. So we don't actually need these two things for now, or actually, I guess we do. So Stephen, 19B is the arbitration ID so remember each CAN message has a arbitration ID, which tells you the system where, what node of the network it's coming from, and followed by the actual data packets. So 19B is the actual module. I don't know if the virtual module that that sends the command. Okay, so I'm just going to do CAN sniffer, and I'm going to pass in. I'm going to do -C, and you'll learn why later. So by running the -C, it'll highlights all the bytes that are changed from the previous command. So it's kind of, there's so many nodes here. I think there's about 40 nodes, virtual nodes. So it's kind of hard to see what you're doing. So like even if you do anything, like I'm just gonna select this. Like I'm pressing my acceleration button and stuff like that. And you can't really make heads or tails of what's going on. So there's something we can do called notching. So we can save all the bytes that we see on the screen at this moment. So you can do it by running, if you see on the left side here, hashtag and the enter key. So I'll just run this a couple of times, and you can see this red slowly going away. I'm just going to keep running it a bit more. Okay, this is very easy because like this is a virtual simulator, and it's sending the same 2 or 3 patterns over and over again. So it's easy to like take all those messages out. So now let's try to see if you can see. I'm just going to cover up my slides. Oh, whoops. Then I'm going to press the acceleration key, and you can see there's 1 byte. I guess you can't see me point with my finger, but you can see that there's 1 byte that's changing. So, and I'm going to try doing that same thing for the acceleration command, or sorry, the left blinker. And you can see that there's 1 byte that's changing on a different ID command. Not a command, sorry, a different CAN ID. So this is like still very cumbersome because there's like still so many packets just flying past you. In actuality, you rarely use CAN sniffer like from the command line. You would use like a GUI thing called like something like Savvy CAN, and that's like much easier to see the changes. And I'll demo that later. So, well, I guess I'll demo it now. Sorry, I forgot how my presentation went. So, originally I had this in the prerequisites, but I thought it would be a little bit too hard for to get 3 different programs installed for this test. It's saving, Chris, it's saving the bytes when I press pound key plus enter. It's saving the bytes to in memory, and you can output that into a file later on. So it's not just clearing the red. It's saving the messages. Because how CAN sniffer works is that it stores the previous data message, and once it gets a new message, it compares between the old one and the new one, and then it sees, okay, which bytes it's changed, and it highlights those bytes. I haven't used Wireshark for this because I use Wireshark for like TCP stuff, but it's not really built for CAN messages. I'm pretty sure it has an extension. It can read CAN. It can connect to socket CAN, but it's not the best. There are better programs for it, like SavvyCAN. I'll just demonstrate it for you right here. So we're going to use the CAN sniffer, and you can see right away it's like a lot better here. So there's a couple of commands. I'm not going to go through it right now. So I'm going to do the same thing before. Instead of running a hashtag and enter, I'm just going to click notch. So then I can mute notch bytes. I'm going to fade inactive bytes. You can go down to the bit level, but that's a little too much information for us right now. So then I'm going to do the same acceleration command. Okay, there. So right now I can see that it's 244. The acceleration command is tied to. So it's a lot easier to see it with a CAN, like with SavvyCAN. But obviously I can't get everyone to install that program. And I'm going to do the same thing with the signals. And you guys can see that it's 188 is the CAN ID for those signals. So I'm going to just close out of this net for now. What else should, okay. And if you guys want to do the playback, that SavvyCAN also has that functionality, but it's still cumbersome to start with the 75,000 line file and just slowly trim it down. Sorry, this is not the file. I think it's not the, oh, okay, there we go. So this is not the, this is not to the, sorry, I lost my train of thought. I think it's, yeah, capture bisector. So this is, you can do this a little bit easier. What we're doing before, where you're splitting the files into smaller files. So you can do it, there's a lot more options here. You can just split IDs like based on the range. So the thought behind this is that the lower numbers are reserved for high, for more valuable sensors and stuff that need to be sending all the time. So for door unlocks, we can probably choose like a higher ID to start with. So that's one other strategy you can use. Stephen, I'm going to cover how to do this on a real car in the later half of the presentation, and I'm going to go through that. Just ask me that afterwards. So yeah, so this is a little easier, but it's still cumbersome. So I'm going to show you another way I interact with the stuff. I'm going to do how I can do it with Python. So the strategy is similar to, it's a little bit different to before. I'm not sure if it's possible to run on embedded devices. Grammatic, I'm not sure if that's right way to pronounce it. SavvyCAN is pretty relatively intensive for embedded devices. So I'm going to do a demo with Python, but so I already did this before. I'm just going to show you the results of it. So the strategy is pretty simple. You record ICSim when you're not inputting anything, like, so you're not pressing any keys or anything like that. Sorry, excuse me. So you're not inputting anything. So you have like the ICSim in an idle state. Then you record another file with CAN doing an action that we're interested in. Then we can compare the two log files to find similarities and differences. And with Python, you can do it a little bit easier. So this is the code. You have I'm not going to go through the code right now, but you guys have that in your workshop files if you know Python and you want to go through it. So I'm going to first open up the ICSim baseline.log. So, and it downloads into a table. So that's the idle one, ICSim in an idle state. Then I'm gonna go through each ID and count how many times it appeared in the log file and how many times, how many unique packets there are. So this kind of pulls back the, what you call, it pulls back the curtain, I guess. And you guys, because it's like ICSim it's a simulator. So you can see that there's very few unique data packets. Oops. So I do that again with a file where I toggle the signals left and right, and then I compare the two. Or sorry, I go through everything and count it again. Then I compare the two. So in this case, because it's a simulator, we can see that's 188 is more present in one than the other one, and 244 is also present in another one. So those are the two inputs that we inputted. So that's pretty easy to see going through Python. That's one other way of doing it if you're comfortable coding. And one more thing you can do with Python is that socket CAN, what it actually does is that it extends like the TCP sockets that you would normally use. So you can connect to vCAN through Python. I haven't done that, but that's something you should be aware of if you like that approach better. So obviously, like there's like much more complicated analysis possible. We can do change in real time, change in like more complicated frequency changes. So I guess I'm nervous. My mouth is drying out. But so in the car messages, or sorry, in the workshop files, I sent you guys. I have the files I was talking about before, the ICSim baseline and the signals. If you want to do it again with your own programming language that you like. But I also included the data files for my vehicle. It's 2016 CRV Honda with the Touring Trim Edition. And I recorded it in different states. So I recorded it, you can record it, I recorded it in driving, and I recorded it while it was sitting idle in park. I recorded it by jamming all the buttons on the steering wheel. Then I recorded it turning the steering wheel one way and the other way, and toggling both the signal and the wiper stalks. So yeah, there's that. So and I'm gonna use those for running the command. So I'm gonna use those files for running CAN player, and you guys can do this too. So you can see how much more information there is in an actual vehicle. So I'm going to close out of the ICSim. I don't think we'll need it anymore. Yeah, this is our last exercise. So I'm just going to force quit. I think like when the engine light comes on, Will said, I'm going to repeat the message for people who can't see it. Do cars store a log for diagnostics or anything? I'm not sure. I think it varies by vehicle, but typically when you see an engine light turn on, they do store some information. So you don't have to like always have it running. So, but only for like certain cases, and I'm sure it varies by different makes. So I'm not sure how many people are still following along interactively, but I'm gonna just, oh sorry. I'm gonna run CAN sniffer again. I'm gonna use the Savvy CAN because it's easier for you at home to read it. So I'm gonna use Savvy CAN's sniffer, and I'm gonna run my CAN player.i driving.log. You guys you'll be using your CAN sniffer instead. So I'm gonna show you how to do that. CAN sniffer, vcan0. So then I'm gonna run the driving log. I think the driving log is huge. It's like 10 minutes of driving, me going through Tim Horton drive-through here in Canada. So it's a lot of information. So, and you guys can, even while it's interacting, CAN sniffer, if you type in C and enter, it'll turn on the color again. So I'm just gonna let it, I'm just gonna keep notching, and you can, okay, so like, there's a lot of data here. So Piotric, Piotric asks, are there any downsides of repeating thousands of CAN commands into an actual car? You should never replay stuff into a moving car. Whenever I've done it, I always done it in park, and I always done it in park. So, and I have my wheels blocked off, so the car can't go anywhere. And the newer vehicles have like an electronic transmission, so you have a danger of like putting into gear using a command. So, Steven says, I don't really understand what notching does. So basically, what notch does is that it saves the data to a file or a memory. So let's just look at this. So here it says 50 FF, right? So if I notch that, it'll fade it to, so the next time there's FF in that data spot, it won't turn on red. We can discuss, I'm gonna discuss that with a real data car, playing stuff, translating this to a real car pretty soon. So, so we're almost done this stuff. So decoding signal, a couple of people asked me beforehand, like to spend some time decoding signals. And this is a very labor intensive process. There's like, as far as I know, there's no easy way of going through it. It's just like a lot of labor. So I'm just gonna turn off this CAN sniffer for now. Oh. Okay, let me just shut this off. So if possible, find someone else, somebody else who already did it. That's what I did. And that saved me a huge amount of time trying to decoding files. So the way you get this information is passed around is something called a DBC file. It's also, I also included that within your files that I had you download, so you guys can take a look at that before. So I'm going to show you on how it works. So here, I guess I'm just going to make sure it doesn't block anything. So I already pointed SavvyCAN to that DBC file, so it already knows like what to look for. So I'm going to click Interpret Files, and it labels all the packets that we have data for. So one of this is, I don't know what this actually is. This is break, so it tells you if you're holding the brake, I think. I'll go to one that I'm familiar with. So I'm just gonna deselect all the IDs here and 14A. So this is the steering sensor. So it decodes all of this data into its individual components. Because there's no standard to how you how a designer can pack information into 8 bytes. They can do it however they want. They can do it in 1 bit, or they can do it in 1 byte, or they can do it in a way that's not on a clean byte, they can straddle 2 bytes too, right? So it's not a very clean way to do that. So so I'm going to demo. So yeah, this is. So I think that's all I have to show you on that. Actually, I think I can see. I'll show you how and you don't want to edit a DBC file by hand because it's very error prone. You want to use like an editor. So let me find that steering wheel sensor again. Okay, so let's look at the signal cancel. Let's look at the signals here. So let's look at the steering wheel angle. So we defined it that 5 and 6 is the byte, are the 2 bytes that the steering angle is stored in. So here I'll show you on the right side. It's 16 bits, so that's 2 bytes. It's a signed integer, and the scale value is -0.1. So basically what it does is that it takes this signed integer and multiplies it by -0.1. Bias is just, it's a number that you add to this byte. So here in this case is 0. Min value, max value, and units name, these are all informational. They don't actually affect anything. So it just tells us like what we should be expecting. And receiving nodes also, also informational. Multiplexing, I have no idea. I never used that. So, and the cool thing about SavvyCAN, I want to show you guys before I forget, is it has really good documentation. So if I say SavvyCAN and I type in signal editor into Google, the first link is the documentation. So I suggest like it's a good place to start if you guys can get it running on your systems. And it's really, really helped me out a lot. So, okay, where am I? Okay, so I'll show you, Don, I'll show you where I got my files. So a couple of people already mentioned it in chat. It's called, there's a company called Comma AI. And what they do, I'll just get to your question in a second, Isaac. What they do is, well, I'll just go to their website to see a little, maybe it's easier. Comma.ai, I think. Oh, comma.ai. Okay, I guess it's not that, maybe not explanatory. So it's just like a self-driving car that you attach to connect to a self-driving module that you connect to an existing car. So So here, I don't know if you guys can see, there's like a phone-like thing here that's connected to the car behind the reverse mirror. I don't know what you call it. A reverse mirror. So it's connected into the CAN network that way. And it just basically does something like a level 2 driving, I think. So we can do basically what a Honda does. So this is here, you can see this Toyota vehicle. And Toyota and Honda vehicles only have like basic lane keep and advanced cruise control. But this does a little bit more on that. So for that, because of their needs, what they did is that they started something called an OpenDBC file. So here, I don't know if you guys can read this. This is very small. Okay, here you can see that they have files for a lot of models of vehicles. So here, there's only files they only focus on cars that have self-driving abilities. So cars made from 2015 onwards. So if your car is like less than 5 years old, it's likely that you have they already have some of the CAN messages decoded. Obviously, they only care about the messages that they need for self-driving, and this is a lot of this is volunteer contributed. So so it all depends on the amount of data you get. It depends on the person who did the work. So the minimum is all the steering actuators, steering sensors, kinematics, radar, and all that stuff. So this is how I found my file. But let's say you didn't have that. What would you do? You had to decode stuff from. You have to decode something from nothing without any prior knowledge. I think it's still good to go through DBC files to get a sense of how messages are structured, even if you don't have the car. So it'll get you in the mindset of how people lay out signals within messages. Yeah. Yeah. There's a lot of questions that I went by, so I'm just going to make sure Okay, so there's a couple of Savvy CAN questions. So I'm gonna, hopefully this doesn't close down. Okay, there we go. So to load a DBC file, you go into DBC file manager, and you can either create a new DBC file or you can load one, and you navigate to where you have it stored and you load it in. So it's very simple. And someone also asked how they can connect to vCAN through Savvy CAN. So here you open up your connection settings from this tab here. Then I'll just say add new connection. Savvy CAN can connect to a lot of different interfaces. So if you have a serial connection, you have a network connection, so you can connect to an IP address, or you can connect to socket CAN like we discussed, PCAN, and they're tiny CAN. I never use these terminal stuff. So let's add another virtual network, vCAN 1. So, oh, okay, I don't know. Okay, it's not connected because we don't have that interface existing. So, okay, so I'm just going to scroll down. Okay. So, I forgot where I was going. So yeah, decoding files. Let's say you don't have a DBC file like many people who have a car from the 2000s, early 2000s. So what's one thing you can do is that we can go through the same thing that we did before. Like these are the files I introduced you guys beforehand. So I recorded my CRV in different states. So I'm going to use Python, but we don't have to go through the code. It's just basically the same thing I did before in the earlier demo. I'm going to load all the logs into the the Python tables, and I'm going to compare the steering wheel log, the unique IDs from there to another table, in this case idle, when it was in idle mode. So I'm going to see what IDs they overlap. So Will asks, does OBD2 specify a standard a set of messages so we can work on any vehicle? Yes, it's. I think they define like 10 or something. That's only and some of them the manufacturers have to implement, and some of them they don't have to. But it's very, very basic information. So you're not going to get anything useful out of it. So if you ever had to check an engine light and your mechanic runs something on it, so that's what those standard commands will tries to find. So there's nothing. There's only like 10 or some commands that it specifies. Everything else is up to the manufacturers. So like I was saying before, I'm comparing the steering wheel log file to when it's idle. It's cut off here. So, and I'm comparing how many unique data frames each ID has to another. So as long as they're in both files, yeah. So I'm just gonna. I'm trying to find the steering wheel ID we had. So you can see this better on your PDFs, but like I would like you to focus on this. So in one file we have 291 unique data frames, and the other one we only have 20. So that's one. So then we go back to Savvy CAN. So let's uninterpret files. So let's find that same packet again. So and let's do which one do I want to do first? I just want to see how did I lay out my information. So yeah, I narrowed down to these two files or these two messages. Then I'm going to demo it in Savvy CAN. So there's something called the flow view, and I'm going to find the same packet we found before, which is oh yeah. First, before I do this, I have to clear these files and file load the steering wheel files. So workshop files, touring, steering wheel turning. Right, there we go. So I'm going to clear all these flags. 14, which is the one we found, 14A. There we go, 14A. So then I'm going to go back in here and say flow view. I guess it's behind here. So this is very interesting. I think you guys will like this. So let's go find the same packet here. 14A, there we go. So here it graphs. Can you guys see this okay? I don't think it's being blocked by anything. But we can just play back and we can see each line represents a particular data byte here. I'm just going to stop it because it's very distracting. So each line represents a different byte in a car. Sorry, not in a car, in that message. And it shows you how it changes. So if you guys notice, so let's just start from the first. Yes, we're on the first frame. Then I'm going to play through it. I'm going to slow down the playback speed to something that we humans can keep up with. So let's say 100. So I'm going to play it. And notice how it's very still. So I first recorded it while not moving the wheel. So the steering sensor has no reason to input anything in a neutral position also. And you notice that when it goes crazy, that's when I'm turning it one way and the other way. Let's see. Okay, there. Right here, I think it'll just jump up here. I'm just going to stop it. So before, from previous knowledge, when we looked at our DBC file, we knew that 5 and 6 were our key bytes that our steering wheel sensor is stored into it. Oh, thanks, Isaac, for the encouragement. these 5 and 6 is the place where it's those things are stored. So yeah, I'll explain what that flashing colors mean. Yeah. So I want to see if I can. I'm going to try to find it. So let's just go through our file. So here, I'm gonna try to go through slow. So here you can notice that all the data packets are pretty constant, and all of a sudden they start changing. So here, 5 and 6. So let's see, saying this is the first data byte. So 0, 1, 2, 3, 4, 5. You know what? This is not. It's hard to see. There's another tool. I think I can maybe. Let's just stick with this for now. Let's just say you already knew that 5 and 6. You suspect 5 and 6 is where the data is stored, but you don't know if it's assigned int, or if you don't know if it's a normal integer or whatever. So let's assume it's stored in most significant bit first format. So 5 is the leading digit, and 6 is the ladder digit. So 6, there's one cool feature here, is I can enter a byte. So it will play back the files, and it will stop at any frame that has FF in the 6th byte. And I'll show you what that means. So nothing. So because the steering wheel is not being moved, so there's nothing. So when the lights flash, that's mean like there's data being changed. So that's what the flash of colors mean. Okay, here. Hopefully it stops. Okay, it's very complicated here. I hope you guys can see it. It's very, very faint. So 5 is the yellow. So here it goes from 0 to its full value, to something about 250 some here, and the 6, the cyan, goes down. So I'm going to show you, and get it what I mean. So if you guys have any knowledge of, let's just use decimal numbers. So let's say it's 0, 1, 0, 2, 0, 3, and so on. And let's skip to 0, 9. So it rolls over to 10, right? So 1, 5. So that's the same thing that's happening here. The cyan, so the LSB, so the least significant byte, is going to 0, and the yellow is going up to full. Now this doesn't really make sense, because why would it go all the way to, in this analog here, it would be something like it's going all the way up to 8 or 9 in the first leading digit, right? So then you have to remember, oh, this is a signed integer. So it's the leading bit, if it's turned to, if it's set to 1, that means it's a negative value. So this is how you can tease out if it's what kind of integer it is, if it's a float, or if it's I don't think you can do floats here, but if it's an integer, it's a signed integer or unsigned integer, so on and so forth. There's another tool also that may do it better for some frames. So I'm going to just close this, close without saving. I don't know if that made sense to people. Just watching the bytes roll over. Making sense? Yes, no? I guess so. Let's do, we just did flow view. Yes, we did just do flow view. Now let's do signal viewer. Is that it? No. A temporal graph is something I can show you really quick. It's very messy, but it just highlights something. It just graphs it whenever it sees a packet. So you can see some packets are very very rarely occur, and some packets are on all the time. So this is like some very easy tool to like see if there's any outliers, but most of the time I didn't find much use for it, but you may in your application. But graph data, no. Is it? I'm just blanking right now. Range state, that's what it is. Okay, so this is a pretty cool tool. I'm just gonna select 14 and just another, and we're gonna figure out if it's, so let's say I ran the Python analysis and I found out 14a is our file that we need, or not file, sorry, our CAN ID that's valuable to us for whatever reason. So, and we want to like parse, figure out what kind of signals are stored within that message. So, we can just, one way of doing it, just basically try all permutations of how you can slice up that 8 bytes into smaller, into signed integer, and do all these other permutations and just graph them and see how it and see what data makes sense. So that's kind of what it's doing, but it's in a more sensible way. So we know our signal size is 2 bytes. So this is 16 bits, 16 bits. And we can try both. So is it big endian? I don't know how to pronounce that. So that's MSB, or little endian, so which is LS, least significant byte last or first. I might have mixed those up, but I think it's right. So we can try both. What granularity is, I'll try to demonstrate it here. So let's just open up our manager. How do I open this? Edit, there we go. Forgot how to open up my DBC file. There we go. Edit. Okay. You know what? I'll just use it on a flow state. So granularity, what it does is, let's say you're looking for a 4-bit message, and you have a granularity of 1. So it starts on a 0th byte of the message. Then it tests for a signal from here, 1, 2, 3, 4. Then it tries that. Then it moves up 1. And if it doesn't find anything, it moves up 1. So 1, 2, 3, 4. So it keeps going. So we're looking for 16 bits. So it's going to move 16 bits up by 1 bit every time. So obviously, the smaller your granularity is, the more longer it will take. So, so let's just assume that they're going to do it. They're going to place the signal on a clean byte layer, right? So, I'm sorry, I closed it again. So let's just assume that they're going to only place a signal on like about like a byte layer. So here, 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 something like that. Okay. So many windows. Okay, there. So I'm just going to say, that's why I'm going to say 8 bits. So we'll try on every byte layer. Then we're going to recalculate signals. Oh, I guess we found something here. So we can see this starts on the 32nd bit, and that's not what we found. So if I go back to the flow view, if I go back to the flow view, I say 14A, we know it starts on the 47th bit. So let's just play around with our settings. Okay, let's play around with our settings. Let's lower our granularity. Maybe that will help. Okay. So I don't know if you guys can see. So it sliced up all the ID bytes. Sorry. it sliced up all the message bytes into different lengths. So here it started at the 4th bit and read the next 16 bits in assigned big endian notation, and this is what it got. So we know our stuff started on the 47th bit. So here, this is probably what we're looking for right here. So if you look back, so we notice that it's 44. So that kind of makes sense. So the first 3 digits or bits were probably blank. So that's why I didn't pick up on that signal there. So that's one way of finding signals within your data. There's a lot of, you can get like, I don't want to do all of them, but let's just do it with a larger data set and hopefully it doesn't break. Oh, we were out of time, I guess. Is it 9:30 that we're done, Dan? Or is it?
Yeah, we've still got about a
Okay.
half an hour till we get to the keynote address and the Hackaday Prize ceremony. So we've got some
Okay.
time. Maybe you want to leave 15 minutes or so for questions?
Yeah, I'm almost done. So I thought I just went
Okay.
over time.
No, we're good. Everybody's just talking about what time it is where they are.
Okay. So yeah, so we can look at other tools. So here, it didn't really find anything in this data set, but I hope you got some sense of when you'd use this tool. It's a really great tool for finding signals. But I would recommend whenever you're decoding signals, is that you have some idea of how the signal will look, like have a hypothesis. Like put yourself in the designer shoes. So let's say, okay, if I were the designer, how would I store this signal into a message, right? And do a hypothesis that way, and then test your hypothesis. That's like much better than just generating a huge amount of signals and trying to go through all of them. It'll be overwhelming. But sometimes that's the only way. But I would suggest put yourself into the designer's shoes first. So we did range state and flow view, and this is really, really cool. The next tool is, okay, let's do file. What did I just say? Frame data analysis. Okay. So let's go back to our steering data sensor. Is it 14A? That's it. I know someone complained about seeing that it's all I saw was just flashing red when I was demonstrating a tool. So you guys can see why that is. So the bottom axis is time. So this is again looking at the steering wheel sensor. So it's not emitting, it's not changing anything, and all of a sudden it just outputs a huge amount of data. Okay. So I think that might be, so yeah, so this is a good way of figuring out like when to start looking at a byte or something. So I'm just gonna look through some other things. So this one's active all the time. So this is constant. So this might be like a temperature sensor or something like that, where it's not changing all the time. So I'm just to give you an idea. So I think is that all it? No, I have to. So yeah, moving to the real world, just a safety, on a safety thing, careful working in closed spaces. Here in Canada, it's getting cold, very, very cold. So the temptation is to move into a closed space and do it. But like you're gonna get, just be careful of CO2 poisoning and stuff. I would avoid working in closed spaces because that's really, really dangerous. I would suggest blocking wheels off, especially if you're injecting things into the car, and even if you're not, because if your hardware kind of spazzes out on you, you don't want it to take off on you. I know one actor got crushed by his car. Well, not when he's hacking it, but it just shifted gears and it just crush them, push them against a wall. So it's very, very dangerous. It's like 3,000 or 4,000 pound vehicles. So we're dealing with, so it's going to win in a fight. So another way of doing it is elevate a car on jack stands. If you never done that before, I would talk to friends who done that before so they can teach you. And when you're finding when you're trying to find hardware, find something with great documentation, because this will save you hours and hours and hours of time. So I made the mistake of choosing on hardware that was deprecated. I didn't realize it at the time. So I had to like go through their. Thankfully, it was all their files and stuff was on GitHub, but I had to like read all the files and figure out how to get it running. So I must have burnt like 20, 30 hours on that. CAN protocols you'll run into in the wild. We didn't discuss it here. So there's something called CAN FD. So that expands the data length to 64 bytes. And this should be you'll only see this on like newer vehicles. I think it's 2018 and onwards, but it's not going to be in every car. And this is like much more faster data rate, bandwidth, sorry, than what we looked at. I'm not going to speak more on this because I don't know, I never used one. And there's another thing called ISO. I think I misspelled this. It's ISO-TP, I think, not top. So this is basically a protocol that, let's say you have a byte that's larger than 8 bytes, and you want to package them across differing multiple frames. This is a standard that tells you how to do that. So I never ran into this, so I'm not going to speak on it. So CANopen, another network. So another, not network, but another standard, I guess. So these are something to be aware of. So selecting hardware. So cost is the big issue. The one I chose was like 130. It's Comma AI's like a CAN reader, but they deprecated it, so it's not something I would recommend. So the cost varies based on how fast it can read and how much memory it has. So if you choose a device with a small amount of data memory, it's going to keep dropping bytes, and you're going to have a hard time trying to find the packet you're looking for because it's never captured, and you're going to chase your tail. So and form factor, if you want something that's small and can connect into your OBD port without being obtrusive, that's going to cost you. And especially if you want to read, if you want something that can read on multiple CAN and other on other buses simultaneously without dropping anything, that's also going to cost you a lot. So, and also you should look at what kind of API it will support out of the box. So socket, CAN, serial, whatever. So that's like one less thing you have to implement to get it to work with what you want. A logic analyzer might be the best place to start. I have something called Discovery, Analog Discovery, something like that, and it supports it. But you just have to be careful because the CAN, I think, signals is at 12 volts, plus or minus 12 volt, and you have to drop it down to 3.3 volts. And I'm going to recommend you a book called Car Hacker's Handbook. It was written in 2016. It's some of it's out of date, but most of it is really, really good. And that's a good place to start if you want to get more into VEETs. Or I'm just going to home. How do I get to home? So I'll just show you the table of contents, what it covers. So it covers like SDR stuff if you want to try attacking the wireless stuff. If you want to attack the ECU, which is I think the engine control unit. So there's like a lot more stuff in here than I didn't cover. So this is a good place to start. Yeah, so that's the thing. And Open Garages has an email list. I'm not sure how, oh, I guess I didn't copy the thing. I'm not sure how active their email list is. I'll update the file and put it back up with the actual link. It's not very active, but it's a Google Forms, Google email list, I think. So it's very searchable. So Comma AI is also a thing. We talked about it before. So they have a GitHub with like almost their entire product open source. So it's a very, very good place to look into. So we discussed the OpenDBC files before. And one other tool I ran across into, I'm just still figuring out how to use it. It's not so much for reverse engineering, but if you're developing CAN networks, CAN Dev Studio is a cool thing to start. It can simulate, you can set up CAN networks and simulate it. I'm not going to spend too much time on here because I haven't used it too much, but it's something you may want to look into. Any questions? Okay, we have 20 minutes, yeah. So
there's one in
Greg,
the chat there.
Yeah, Greg asks, Amith, in your experience, are current gen cars implementing any measures specifically to prevent manipulation, injection of messages, or are the CAN buses basically a free-for-all? So yeah, you know that the car door trick I showed you about recording the CAN messages and playing it back, that may not work on a lot of cars, because basically on the OBD port, they might put a firewall, and the firewall only allows certain messages from getting through. So yeah, so that's going to be a limitation. Okay, so let's see. Don asks, are CAN IDs from TMPS dashboard light manufacturer specific or standard? I'm not really sure about that, and I don't know how that functions. So you have to look it up, and there's a lot of hacks that have been done around that. So if you just Google around it, you'll find something. What's the advantage of running CAN at 12 volts? I'm not really sure. I think that just historically how it happened, how it worked, because I think the car battery is at 12 volts, right, for most things. So maybe it's that. So yeah, Alex says that TPMS is manufacturer specific. Will asks, are there a lot of response messages? For instance, drivetrain systems sending response messages to steering input. I'm not sure. I haven't dealt with anything that requires sends and receives the command. I looked at very, very straightforward things like steering wheel sensors, whether your foot's on the brake pressure, acceleration, stuff like that. I haven't looked at anything that's more complicated than that. Alex says it's CAN plus or minus 5 volts, so that's my bad. You can reach out. Isaac asked me how you can connect to me. You can send me an email at I don't want to say it here, but you can reach out through me. You can reach out to me through hackaday.io. So there's a public chat, and we can talk there, and you can direct message me, I think, too. So. Okay, Greg says that there's a better signal integrity with plus or minus 12 volts or a 5 volts. So that's good to know. Anything else I can help anyone with? I'm sorry that everyone couldn't get their thing set up. It's a little complicated thing to set up. So I hope everyone got some use out of it anyway.
I have a kind of an oddball question here that might be a little bit out of your wheelhouse, but
okay.
I'm just kind of curious. It appears that newer cars have actuators and you know, on the steering system and sensors for steering angle and stuff like that, which you know is news to me. I'm kind of a Luddite when it comes to cars. I like them old, but Is that when about did that start? Is it really just for cars that can do like lane departure correction and things like that, or?
Yeah. So anytime you need it needs to correct the steering wheel, like so lane keep assist. So I think in my car, my old Accord used to, well, old is 2015, but it used to kind of fight you if you're drifting out of a lane. So and more some cars, even my Accord and HRV can navigate curves on their own. So in addition to cruise control, they can take some basic curves, not something crazy. So they can take basic curves as well. So yeah, so anything that has like the advanced stuff, like the automatic braking, lane keep, that's where you find these systems. Before that, there's no need for it to exist. I think also like some cars had self auto parking, so it might have also been implemented there. So that might have been before all this lane keeping thing.
Okay, cool. Well, maybe one day I'll buy a new car and have something to play with too.
I think you can still do some hacks with the older stuff. I haven't done this, but you can. I know people try to mess with their ECU to get more horsepower or different performance. So
Yeah.
that's something you might want to try, but you can break it. So that's not that's the only downside.
Practice on a rental car.
Yeah. One thing I saw, like if you look at the car hackers handbook, is that they pull out old parts from like wrecked cars. So especially if your car's popular, you might be able to find salvage components and just run them up independently and just test on like isolated components and just hook it up to power and see what it sends. And you can input something to it. They cover it more in the car hackers handbook, but that's something you guys can do it. Look into if you're trying to do something more intrusive and you don't want to break a vehicle and you just want to mess around with something simple.
Okay, cool. Thanks. Before we lose too many more people, which we haven't lost that many, but we still got quite a few in. I want to make sure we put in a pitch for the keynote address that's coming up in 13 minutes or so, plus the Hackaday Prize ceremony. So we get to find out who won the Hackaday Prize this year. So make sure I put the link in there. That's a live stream. Go and check that out if you are so inclined. Anybody else have any questions? We could probably free up some mics now if you want to just ask instead of type.
And I'll be available on the public chat. So if you guys want to ask me questions later on, I'm glad you guys enjoyed it.